All right, today we're going to pull back the curtain on something really powerful. It's the secret that the best companies use to deliver perfection, not just sometimes, but every single time. We're talking about statistics and how these numbers become your secret weapon for nailing perfect quality. So, let's just start with the big question, right? How in the world does a company guarantee that their product is great? Not just the first one off the line, but every single one that follows. Whether we're talking about the perfect cup of coffee or a critical medical device, how do they get it right consistently? That's the puzzle we're going to solve.
And the answer really starts here, in our first section, why quality needs numbers. It all boils down to a fundamental truth. You simply cannot control what you can't measure.
Think about it this way. You've got a chef, right? A culinary artist who just feels when the sauce is perfect. It's all about instinct, it's subjective. But then you have a food scientist. They're not just feeling it, they are measuring it. They're checking the pH, the viscosity, the temperature. They use data to guarantee that perfection. Well, in business, we have to be the scientist.
And this whole scientific approach, it has a name. It's called quality management. It's basically a company's formal promise, their deep commitment to consistently meeting or even exceeding what their customers expect. And this isn't just some vague mission statement, it's a structured, all-hands-on-deck philosophy for the entire organization. So here's the key takeaway. Statistics becomes your toolkit. It's the thermometer, it's the pH meter, it's all the precision instruments for your entire business process. It's what gives you the power to really measure what's going on, analyze it, improve it, and most importantly, control it.
Okay, so now that we get why we need numbers, let's see how they actually help us make some really high-stakes decisions. This is where statistics stops being theory and turns into a powerful tool for real-world action. Look, in quality control, you're always making judgment calls, and there are two major ways you can get it wrong. First, there's a type 1 error, or a false positive. That's when you think something's wrong and you scrap a perfectly good batch of product. Then there's the type 2 error, the false negative. That's when you think everything's fine, but you end up shipping a faulty, maybe even harmful product out the door.
Let's make this feel real. Imagine your quality test flashes a warning. The call is made, you just scrapped a perfectly good batch. That's money right down the drain. That's your type I error. It stings, it hits the bottom line, it's wasteful for sure, but the damage stays inside your company walls. Now flip that. Imagine the test says everything is A-OK, but it was wrong. And now the call comes in. You just shipped medicine with the wrong dose. The damage is unthinkable. That's a type 2 error. And the cost there? Oh, it's not just money anymore. It's customer trust, it's public safety, it's your company's entire reputation on the line.
So how do we possibly navigate these risks? Well, we use a structured, disciplined process called a hypothesis test. Let's walk through a quick case study. Imagine a machine is supposed to make steel rods that are exactly 5 millimeters thick. To check if it's working right, we follow these 4 steps. We state our assumptions, we calculate some numbers based on a sample, we find this one magic number called a p-value, and then we make a final call.
So after we do all that math on our sample of steel rods, this whole complicated, high-stakes decision, it boils down to just one number. This is what's so incredible about statistics. And that number, the p-value, is 0.036. So what on earth does 0.036 mean? Well, in statistics, a common cutoff point is 0.05. And since our number, 0.036, is less than that threshold, the verdict is clear. The machine is faulty. The difference we measured wasn't just a random fluke. No, it's a real problem that we need to fix. And we know that because of data, not just a gut feeling.
Okay, so we know how to make a clear go or no-go decision. But what if we want to get ahead of the problems before they even happen? Well, that brings us to our next big idea, finding what actually drives quality.
To find those drivers, we use an amazing tool called regression. Honestly, it's like uncovering the hidden recipe for your product. Take making a bag of potato chips, for instance. Regression can tell us exactly how things like machine speed or the pressure in the hopper affect the final weight of the bag. We learn which knobs to turn and by how much, so we can dial in the perfect settings to get that flawless 1 kilogram bag every single time.
So we've made our decision and we've figured out the secret recipe for quality. But how do we stay on target day in and day out? That leads us to our final section, keeping processes on track. The #1 tool for this job is the control chart. It looks simple, but don't let that fool you. It's incredibly powerful. It's got 3 main lines. You have the center line, which is your target, your goal, and then you have an upper and lower control limit. Just think of those as the guardrails on the highway for your process. As long as all your data stays between those guardrails, you're in a good place.
And this is what that looks like. This is a healthy, stable process. You can see the data points, they just kind of bounce around randomly between the guardrails. This is normal. It's what we expect to see. The process is officially in control.
But then you see this. One single point flies way outside the guardrails. Uh-oh, that isn't just random noise anymore. That is what we call a special cause. It is the control chart waving a giant red flag, basically screaming at you to investigate right now before you end up making thousands of bad parts.
Now, of course, there isn't just one type of control chart. It's all about picking the right tool for the job. Whether you're measuring something continuous like weight, or you're just counting simple pass-fail defects, there's a specific chart designed to monitor that exact type of data.
So we've gone through all these tests and charts and concepts. What's the real takeaway here? What's the bottom line?
It's actually pretty simple. You've gone from just crossing your fingers and hoping for quality to being able to guarantee it with undeniable data. You've literally replaced guesswork with a predictable science.
And that really just leaves us with one last question for you to think about. If the data from your own work, your own project, your own company, if that data could talk, what story is your process telling you right now?